Let's do it.
All right. Well, thank you everyone so much for joining another Balerion Space Venture podcast. Today, I'm joined by Brian Taylor, the founder and CEO of Lux Aeterna. This is building the future with a fully reusable satellite that is able to operate in space and not just go up into space, but come back down as well. A new industry we're starting to see more and more of. Brian, really excited to have you here. Thank you so much for joining.
Yeah, absolutely. Thanks for having me. Stoked to be here.
Yeah, so maybe we can start it off on a high level. If you're explaining this to someone who hasn't heard of you guys or maybe isn't too familiar with the space industry itself, what's your high level pitch to them of what you guys are building and why it's important?
Yeah, totally. The space industry, specifically in the orbit of Earth, Leo, MEO, and GEO, has traditionally been very constrained by launch access and launch cost. That drove a massive, mass optimization of satellites to be the lightest possible to what they needed to do, and that led to an attritable or disposable architecture that is designed for replacement. Um, that's the traditional way that almost all satellites have been built up until now. When launch is no longer the bottleneck and you have a higher supply and a lower cost to launch, you can start loosening some of the things that were previously optimized on those satellites, like mass. And so that's what we did. So we have a slightly heavier satellite, but it has re-entry capability and full reusability. And so when you do that, you get these massive advantages that are similar to industries that we have on the ground, like aircraft, marine, rail, things like that, in terms of the amount of useful life that we'll get from an asset, instead of a one-time use, attritable, disposable architecture. So we are building a fleet of satellites that are built on this new architecture. We perform reentry as a means to that end, but we're not a reentry company. We build a satellite that's reusable, but we're not necessarily a fully reusable. That's not the pure goal. The goal is
Got it.
to use those things to get to a fleet of satellites that are moving up and down on a regular basis, to be more robust, higher cadence, and lower cost.
So now's the right time because the launch cadence has gone up, the cost has gone down. What kind of opportunities does this open up for the industry who can, you know, take advantage of the service you're providing?
Yeah. So we have seen our customers come up with new mission architectures that we didn't really even think of that now start making sense that would never have made sense before. So the things that we provide are a much lower lead time, a much lower cost, and we turn what used to be a constraint of mission duration into a knob. And so you can now design a mission to be 3 months or 6 months or 1 year or 2 years or 3 years, whereas previously all missions were as long as possible in low Earth orbit. That's about 5 to 7 years, and that's kind of one of your going in constraints for a satellite architecture. So we've allowed some of our customers to start talking about designing for a 3 year mission or a 6 month mission, and what kind of value do you get out of that that's different, when you design a payload for 6 months in space instead of 5 years in space. And so it really opens up new possibilities, especially when you combine that with a very low lead time that we're able to offer because of the fleet, fleet dynamics.
Yeah, absolutely. And maybe we can jump back for a little bit.
Sure.
How did you end up here?
Yeah.
Walk us through the story of your career path because you have quite an interesting career path. And when you saw the opportunity to say, now is the best time to start this, and drove you to founding this company.
Yeah, absolutely. I went to school for mechanical engineering, did a master's in mechanical engineering, and actually focused on systems engineering and value driven design, which I then kind of like left abruptly and wanted to get into hardware and building things and testing things. So I was in aerospace and space for about 15 years before I started this company. I worked at SpaceX at the very beginning of Starlink. I did all the structural qualification on the first stack of 60. Um, and then moved over to Starlink Aviation, so putting Wi-Fi on planes, and then spent some time in Amazon's Project Kuiper. So again, more high rate production of satellites. Now Amazon Leo. And then I was also at Loft Orbital as their head of mechanical engineering in order to kind of help them go from to scale up of more satellites in orbit faster. So each of those companies had a different approach to how do we get more stuff in space faster. And I think you see that across the satellite bus market today of these different approaches to answer that question. And I didn't really see it being answered sufficiently. And really, the supply chain problems and the lead time to go from decision on a program to we've now launched was way too long, and the flexibility to kind of do multiple types of missions with the same bus architecture kind of also wasn't closing. And so, with a background in systems engineering design, what we ended up doing a lot was kind of finding one variable to relax and seeing what happens to the other variables in a multivariable problem, and then optimizing on something else. And so, I looked at the mass of the satellite and said, if we loosen that requirement, say it's not quite as critical, what could we do on the satellite? Well, you can make it a little bit heavier to add a heat shield, and then you kind of look at launch costs and you say, well, it doesn't that doesn't break launching this vehicle into space. And then you get kind of the way back, you get reentry. But if you go kind of one step further and now you bring everything back instead of jettisoning kind of half or 75% of the satellite, now you can bring the entire satellite back. And when you do that, fundamentally, you just don't have to rebuild the satellite from scratch for every mission. And that was the pain point that I had, across my career, was even if it was the same design, same vehicle, same flight heritage, you may get a new supply chain problem that says we're out of battery cells, we're out of solar cells for this type. We can't get a specific motor. We can't get, like every component on a one-time use new, like attritable satellite is critical. Like you cannot sub things out. Every single piece is critical and takes some NRE in order to kind of put something else in, and that leads to a lot of delays. And so fundamentally, by just not rebuilding the satellite from scratch, we get this massive gain in operational efficiency. And so that was really the thing that I had painful time with in my previous career, and saw that reusability had solved that really on the rocket side with Falcon 9, and really opened up what you can do with the satellite because the rocket was reusable. And so wanted to kind of pass that on to the satellite side. So that's really the genesis of the company. We started about a year and a half ago, so we're still quite fresh to the game, and moving very fast. But that was the moment in time matched with kind of where we are in the launch industry that said, now is the time that we need to do this, and it's going to solve a problem that I've had personally in my past lives.
Got it. And walk us through the satellite itself, and what this fleet is actually going to look like. You said it's a little bigger. How big? How much can it carry? Does it look like a regular satellite, or does it look like maybe a return pod? If I was looking at this thing, what would I see?
Yeah. If you were looking at this thing, you would see, a front side heat shield, and then all the Lego components of a satellite, kind of stuffed in the back of that heat shield. And kind of fundamentally, that requires us to build we have to operate it differently because we've built a different looking satellite. It does not look like kind of the flat plate of Starlink or the boxy structure of a lot of traditional buses. And that's because we use the heat shield as an integral part of the structure, and we build the rest of the satellite off of that. And so that really changes how we operate it thermally in space. But that helps us meet the thermal requirements during reentry, obviously. So, yeah, that's kind of what it looks like. It's a 200 kilogram satellite with a 20 kilogram payload. So the mass payload fraction is not as favorable as some satellites, but again, that's the sacrifice that you take. That payload fraction will increase with our next generation vehicle, but we haven't released the specifications on that one yet. This is very much Delphi is a technology demonstrator, right? Our goal is to go up, stay up, and come back down, make it work, and then make it work well with the next generation of the vehicle, which will be larger and much, much more capable. So it has all the systems of a standard satellite, solar array, flight computer, batteries, propulsion system, all those types of things. Every single one of those comes back with the vehicle when we return. And so we do have a retractable solar array, and anything that we kind of put out, we bring that back in before we come back from space, and then we deploy parachutes and we land on the ground. One of the fundamental parts of our design is that we land on the ground instead of in the water, because we are going to reuse all of these, and it's not a capsule that is fully sealed from the environment. So the landing on the ground is part of that design.
Yeah, and re-entering the atmosphere, that's the scary part of the mission usually. How do you manage precision, safety, and reliability when you're bringing hardware and customer payloads back through the atmosphere? This is something we haven't seen too much of. We're much more used to things going up into space, not as
Yeah.
used to coming back down. So maybe you can explain a little bit about the challenges and how it actually works when you have a vehicle re-entering.
Yeah. So um, not very long after the first satellite went into space, the first vehicles started coming back from space. So the Corona program was the very first reentry capsules. We caught them with a plane. There's some pretty good videos of how they did it. It was relatively, violent. But we have been doing reentry kind of as a space industry, as a country, since the 1950s, right? So we understand it relatively well. It is usually so obviously any human spaceflight requires reentry, and so usually the reentry involves human spaceflight, and that has much tighter requirements than what I would say what the new space industry has applied to kind of get a satellite up as fast as possible, and it's a very different risk posture. That makes reentry seem very expensive, right? Because it's almost always involved humans. We don't involve any humans on our flight, and so we have a very different risk posture that we can take. So, obviously, safety is paramount on reentry because it's coming back to Earth and it's not just stuck in space. And so we have analysis and simulations that say, based on our orbital operations, this is where we're going to come down. This is the accuracy. We've announced that we're landing in Australia with Southern Launch for the first launch. They've got plenty of space for us to, land on and kind of hone in on that precision. But right now, we're not focused on precision landing. We are very much focused on, coming back in one piece and defining that whole concept of operations and getting very good at that operationally. So, yeah, we have a heat shield, and then we have parachutes, and so it's I don't want to say it's standard, but it is a thing that we've been doing as a country for a long time. So it's not breaking the laws of physics. It's really applying new principles to manufacturing and operations to make it a lot more economical than it was when you're doing that very often with humans.
Yeah, absolutely. And thinking about, going up and being able to come back down, having that capabilities, there's
Yeah.
a lot of new opportunities that it opens up, especially in this new space ecosystem.
Yep.
Things like manufacturing in space, things like being able to run short missions, collect mass amounts of data that might be hard to transmit to Earth, and just being able to send that back down, or simply you want to fix a satellite you have up there or upgrade it. Uh,
Yep.
Going into the future, what are some of the biggest ones you think we're going to see, and maybe what's the real selling point on this when you're trying to convince someone you want a reusable satellite?
Yeah, I think the biggest one is the flexibility and adaptability that our platform offers. And that covers defense applications as well as commercial applications. And that is rooted in getting the hardware back and then having human hands on the hardware. So a lot of things you just described, other than maybe kind of there's a lot of cases where you need to bring atoms back from space to Earth. Re-entry and hardware return is the only way to do that. There's also a lot of cases of switching out payloads or fixing a satellite, um, and you can make a case of doing that with robotics and doing that in space. When we were building satellites for Starlink at a very high rate, we still had most of those operations done by technicians, right? We are not at a place where satellites are just spit off the line by these massive robots like cars or consumer electronics. The orders of magnitude of the scale difference between the number of satellites that we're building today, probably about 10,000 globally, to automotive, which is about 200 million globally, and consumer electronics, which is about 2 billion globally. We are not at the same point where robotics makes sense for the quantities of satellites that we're doing. So instead, we think that doing a thing in space with robots that you don't do on Earth with robots makes that a very hard problem to solve because space is harder than the ground. And so, kind of doing things with human hands on hardware on the ground is really the way that we see kind of that iteration and the speed and the innovation of the payloads and kind of the use cases to come true. So, yeah.
Yeah, and I'm thinking about this of just the future of the space ecosystem, and as things upgrade and improve, satellites that exist today, they're going to want that next GPU, that next in-space computing capability, and they're up there, they're stuck up there,
Yeah.
and coming back down isn't easy. But you're able to come back down, so I could see it in two ways. You can have this satellite that is just always up to spec, up to date because it's reusable, it can come back down, get souped up, go back. Or I can see it as a courier where maybe it can go up with a bunch of payloads, drop them off for other satellites, whether it's you give it to a space robotics company that can go deliver them or you deliver them yourself. Have you thought about that opportunity of becoming basically a courier to existing satellites? Because there's already so many and they don't have the capability to come back and get fixed up.
Yeah. So, there's a couple points to call out on what you just talked about. One is, you're describing changes in the payload, not necessarily changes on the satellite bus. The satellite bus is not actually changing that much year over year or even every 5 years. Every satellite's got solar arrays, it's got propulsion, it's got a flight computer, it's got a battery, like it's got that capability. You may want to go bigger and larger, but you don't necessarily need to switch out those components for the latest and greatest, right? On the payload side, however, it's a totally different story, right? You may want the latest compute capability on GPUs. You may want the latest, hyperspectral camera or something like that. And so when you separate the bus from the payload and say that the bus is actually going to stay stable for, 15, 20 years, and it'll actually be the same actual asset. But the payload can update and upgrade when the payload wants to, right? Some things are on a 5 year generational update, some things are on a 3 year generational update, some things are on a 6 month generational update. And so being able to match your mission to that without matching your satellite to that timeline is actually a really big deal that can maximize the economics for what you're doing in space. Um, so yeah, that's really one of the changes that we see as a result of this. Um, as well as kind of and that goes into why would you ever want a short duration mission. Well, you want to match what the payload kind of wants to do in space and for how long, as opposed to making the payload match the satellite lifetime.
Yeah, and I'm thinking about this. I think of an analogy that pops in my head is currently satellites. It's like if you had a balloon and you just released it, like good luck.
Yep,
You don't really have any
exactly.
control
That's
after
how we
that.
do satellites today, right? And just like that lack of everything's on in Leo is on a 5 to 7 year scale, unless you on a 5 to 7 year iteration cycle, unless you're like eating the cost of doing a shorter mission. And so it really slows down that iteration cycle because of that static, that static deployment cycle where you just kind of let it go and say that's it. We'll see how that one does, and then when it's done, we'll do a new version, but we've got some time to do that.
And then going in the future, we already have so many satellites up, and they don't really have the capability to come back. If we keep this up, we're just stacking more and more on top, and it just gets more and more congested.
Yep.
But this also opens up an opportunity for companies that can deorbit satellites. They can grab them and toss them back down to Earth when they're no longer needed. So I'm wondering in the future, is that going to be a huge market, or is that a temporary relief? And the permanent problem is going to be fixed by more reusable satellites.
Yeah, I mean, the scale that we are seeing people, talk about for cislunar infrastructure, for orbital data centers, is 1 to 2 orders of magnitude of where we are right now, and that's 1 to 2 orders of magnitude in quantity than we were at, just 10 years ago or even 5 years ago. When Starlink came out and said we're going to do 30,000 satellites, it was insane, and now they're coming out and saying they're going to do 100,000 or a million, right? Like that jump in scale, in our opinion, cannot happen with one-time use assets. The capital and the supply chain that needs to support that is just massive, and so we see the scale of doing that type of thing in space as absolutely requiring reusability. In the same way that like getting to the launch rates of Starship with one-time use boosters just does not compute, right? But to get to that massive cadence that Starship is aiming at, everything has to be reusable and rapidly refurbished. And obviously, SpaceX is doing a great job to kind of get there. We think that's also needed on the satellite level as we try and get to these massive scale for the kind of next wave of things we want to do in space.
And as that next wave of space comes, there's so many companies that want to go up to space and do something, and there's a few
Yep.
providers who's able to take them there. SpaceX is the main one, obviously,
Yep.
but SpaceX will have a transporter mission, every now and again. There's like 100, different payloads on board. Like everyone's waiting in line.
Yeah.
So I'm curious of what's going to outpace what. It already seems like the space tech companies that want to operate in space are, orders of magnitude higher than what's actually going up, even though cadence is growing tremendously. So what do you think has to happen in the future to where, being able to go up into space is as easy as buying an airline ticket for these companies?
Yeah. I mean, there's a couple things that need to happen to get to that scale, but all of those kind of result in a much higher supply of, excuse me, of launch capability. And if the only provider for that is SpaceX or Starship, then the rest of the industry is not going to be in a good spot. So there must be valid and useful competitors to SpaceX and Starship um, to kind of continue giving that increased supply while still reducing reducing the cost, right? With Starship, cost will go down. Without competition, price will not go down. And so, that delineation is really important. We are cheering on all of the launch providers and want all of them to be successful, and are in discussions with, most of them. And so we kind of need that entire ecosystem to be successful, not just Starship.
Yeah. And just thinking about this, how big is a fleet of these? How many need to go up to be considered, your fleet? Are we talking, a handful, like five or six, or dozens?
Yeah, I mean it starts at a handful and it goes to hundreds and thousands, right? It is the infrastructure backbone of the scale that we want to see, right? And so when you're doing attritable assets and disposable assets, say the order of magnitude is, one or two zeros larger in terms of the number of assets that you need to create rather than when they're reusable. But yeah, we're still talking about getting to a world where we've got, we start with one, two, three, four. That consists of a fleet technically, but our goal is as quickly as possible to get to tens, hundreds, thousands of these satellites, and it'll be like a fleet of aircraft where there's different sizes, there's different configurations, there's standardization across many of those that reduce those costs, and there's standard methods of operating them. But we do see smaller ones, larger ones, Leo ones, Mio ones, like all that kind of thing.
And just thinking about this capability, it seems like so many people would want this ability. But right now, if you asked, they're just like, well, it doesn't exist right now. So I'm just going to get a bus provider to build me something quick and easy and like a balloon, just let it go and there it goes.
Yeah.
But as it goes on in the future, um, you know, having this, you guys being able to have these satellites be reusable, what's the real bottleneck there? Because it seems like there's so many people who want this. Is it manufacturing? Is it launch cadence? Is it capital?
So there's an inherent assumption that you just stated there, which was if I want to get to space, I just find a bus provider and it's quick and easy and I put it up. That's not true. Like that's just not true. That cost goes up drastically. It's like exponential the closer you get to launch. So if you give somebody 5 years to build you a satellite, it's relatively low cost. If you say, I want to get into space and prove my technology, it's just one little widget on a CubeSat, and I want to do that in 8 months or 6 months or something like that, the cost goes up dramatically into the millions of dollars, right? Even excluding launch. And so I wouldn't say that that is actually quick and easy. I would say, it is relatively quick and easy to get onto a launch. There is a lot more demand than there is supply right now, but we see that collapsing, in the next 2 to 5 years. And so, but it is very reliable. Like the reliability of the schedule of Transporter and SpaceX's rideshare missions, that's what's actually sustained this explosion in the satellite industry. You can't get that reliability on the satellite level. You may kind of order 10 satellites or one satellite to go into space in 2 years. Launch is going to be ready in 2 years, but that satellite is going to be, net 2 years, and it might be three because they couldn't source the propulsion system or they couldn't source, a specific battery or, whatever that is. So it's not actually quick and easy right now. And so this is our way of making it quick and easy in the future.
It's quicker, more expensive when you're doing a
Yeah.
bus provider. That's true.
Yep.
And the
Exactly.
future of bus providers, when you're providing this at scale, all the other bus providers are like, well, we want to do that. We want that capability. You're offering something that no one else really has. It's kind of like SpaceX with the launch. So the future, I see competition. What have you been able to achieve that is going to make competition pretty hard when other people want to start copying you when you're successful and you have these satellites that can do things no one else can?
Yeah. Um, I mean, to be clear, like we think that everybody, or at least most of the industry, will follow us into satellite reusability. So it's not a question of if they kind of come knocking and trying to figure out what we're doing. It is when. And our goal is to get as far out in front of that as possible in the space industry. That's really kind of fundamentally the thing that you can do. The technology itself kind of passes around the industry, but it's the institutional knowledge and the speed that you build, that is really the reason that SpaceX is so successful compared to other launch providers, is that speed. So we are working at breakneck speed. We are continuing to do that, and we'll do that as we scale. And I think that's our main competitive advantage. In that process, like I said, we're designing a fundamentally different satellite than what currently exists. We have to operate that in a fundamentally different way in space. And so it is taking us time and institutional knowledge to figure that out and develop those methods. That's not something that another bus provider can just kind of hop over and decide they're going to do that, right? Like we are spending the time, the energy, and the analysis and the brain power to do that work that gives us the moat around kind of how to do this efficiently.
And we're coming up to a point in just the space ecosystem. The private market, the VCs, we've known this for several years that this is no longer sci-fi. This is infrastructure and it's growing really fast. But now we have SpaceX coming up to an IPO next month, possible
Yeah,
$2 trillion valuation. What do you think that's going to change once that happens and everyone sees it as infrastructure? And a year from now, I'm curious where we'll be with how fast things will move.
yeah. I think there's a lot of implications from that. One of them is that private and public markets that currently aren't interested or feel secure with space as a vertical will start to feel that security and kind of seeing an exit path in the future. So we see a lot more capital kind of coming into the space industry. I think it's going to do a lot to the talent market. SpaceX engineers are some of the best that are kind of produced within the space industry. And when you have a lot of those people that suddenly have a lot of liquid wealth, their motivations change for better or for worse. So I think you're going to see some people that kind of retire early and they're perfectly happy about that. And I think you're going to see other people where kind of money isn't the driver, but the excitement for the mission, the change in the world, that is the driver for them. And so I think that'll really change the talent market that we see. And I think in general, I'm sure you guys read the SpaceX S1, like that gives this trove of validity to what we in the space industry have seen for a long time of space infrastructure being this robust industry vertical of the kind of equal with maritime and aviation and kind of all the other things that make our world work. And so I think that gives validity to what we're doing, and again, will bring a lot more capital and a lot more speed to what we're doing. So yeah, we're really excited about that and what that'll do for the industry.
Yeah, I'm just thinking about last week I was in Texas at Starbase at the
Yeah,
Starship.
yeah,
And I was standing in front of Starship and someone asked me what I did. And I said, I'm VC in space tech investing. This is a space enthusiast. And they're like, oh, wow, that's very risky. And I like stopped and I looked at the 400-foot tall rocket and looked all around. I'm like, look at this. Like, this is happening. You're seeing it right now. This is all real.
yeah,
And it is hard for me to comprehend that he thought there's still so much risk. Even seeing one of the most technical forward companies in the world with the most incredible machine ever built, they still saw this risk and they still are kind of iffy about it. So what has to happen for people once you start going the other way, coming back down to sort of alleviate the risk and be like, that's a good solution, not that's pretty risky.
yeah. It's consistency and cadence. Like somebody at a Starship launch knows that it's a test launch and knows that things might go wrong with it. Like those are very risky launches, and we all watch with excitement because of that. The revenue that Starlink has generated and the growth curve that Starlink has generated for SpaceX is so consistent. And that consistency and high growth rate is what gives investors security. And it means that you can adjust your risk based on kind of known growth and known consistency without these big ups and downs of a rocket blew up and the company might be on the fritz, right? That is risky, but when you're sustained by something much more consistent, then uh, then it's a lot more secure and lower risk. And so our goal is to kind of stand on the shoulders of giants of very consistent up mass and provide very consistent and reliable down mass. And when you do that, you get a lot more trust in what you're going to do in between those two things in orbit.
Yeah, absolutely. And with your experience, the people you've talked to, who's been, the most optimistic and just, yeah, let's do this. I want you guys, or versus who's been the most pessimistic? Is it, space investors who are optimistic or government or new commercial space companies? Like who's really reaching out to you first and is in front of the line, hoping to get, you guys to provide for them?
Yeah, I think there's groups within each of those that are highly pessimistic versus highly optimistic. Investors, customers, government stakeholders. There's certain people that have scar tissue from past experience in space, and there's other people that don't, and they have, rose-tinted glasses. And I think for us, it's about finding the balance between those of folks that are kind of based in the same reality as us, not too optimistic and not too not too skeptical that they won't kind of hop on this ride with us. So as a 1.5-year-old startup that is doing our first mission in February, we have a very different risk posture, and we know that. We've matched to customers that are familiar with that risk posture and kind of are using that as their springboard as they go forward. I think in space manufacturing is one of them that is very nascent industry. There's a lot of risk on their side of kind of proving what they can do, but that makes them very suitable to kind of pair with us because they absolutely need high cadence down mass return. They're one of the people that say, hey, you and all the other people doing down mass, we want you to get to what you're doing very quickly. Um, and so they're definitely one. And then the other one is some of our government customers that really see the potential of new mission architectures that give them capabilities that currently don't exist. And again, going to that short duration, very low lead time, that's one that they're very interested in.
Thinking about, the side things of what you provide, not only do you have satellite can go up, come back down, but you also have, a vehicle that's capable of going faster than almost anything that's ever existed. This thing is going,
Yeah.
what, Mach 20? Mach
Yeah, Mach
20 plus?
25. Mach 25 is kind of starting spot.
And I'm thinking about this in hypersonics being such a, you know, big arms race right now. I'm wondering, the payloads you provide, could they do something during the return to Earth that enable a hypersonic glide vehicle, something like that? Have you explored that?
Um, Yeah, I mean those things are definitely possible. Like the world is your oyster. I can't really confirm those specific applications, but for sure, hypersonics testing in general is a thing that we support and that a large part of our customer base talks to us about, and we're happy to provide that as one of the there's a low count there's a low quantity of vehicles and platforms that can support hypersonic testing, at the speeds and heat levels that we need to really test some of those new capabilities and in other applications. But we're happy to have people test on the way back down.
Do you think there's another stage to this of the value chain of maybe one day there's a future where the payload and return vehicle satellite is all itself a rocket and that alone can go into orbit, come back down, be reused, and you're self-sufficient. All you need is a launch pad.
Um, I mean, I think so. That kind of gets close to, second and third stage reusability. Um, and and the difference between what we're building and something like that is, you have these ginormous fuel tanks that take up, most of the volume of the vehicle. And then you've kind of got to get, liquid fuel in the right spot, in the right time, in the right ways. And so your mass and your uh, ballistic coefficient kind of are in a very different realm from what we're doing on our satellite with our cone sphere heat shield. So I won't say it's like not possible, I will say that, we look much closer to a Dragon capsule than we do to a second stage. And so that can, that has different physics and different things on the heat shield side and what gets protected and things like that. So it's an interesting concept as we increase the vertical integration, but they are kind of different physics problems on the reentry side.
And you're a very young startup, and you've grown quickly. You raised 10 million somewhat recently uh,
Yep.
from investors. What I'm thinking is, if there's investors prospect and he's on the fence, what argument are you able to use that can really change their mind to get them in favor of why this is such, a great idea and the future?
I mean, in general, there's usually a little bit of input of kind of why they're skeptical, so we can kind of go off of that. But I think there's a couple classes there of folks that kind of think this is possible, and it's a manufacturing and operations problem to get the costs to match, and then it's believability of the team that we've built and can they do that, versus folks that are kind of like, nobody has done this so far, so it's probably a bad idea. And there's kind of no convincing folks like that. And so usually I need a little bit more context there, but another one is really talking about the scale that we're trying to hit and going from 10,000 satellites to 100,000 satellites to a million satellites in orbit at a time. Um, that just doesn't, that math doesn't work out to us without reusability. And usually that's a thing that can kind of click in the end.
And is there anything that investors often get wrong when hearing about your company and making their own assumptions? You say they usually have some points where they're skeptical about. What's some of the common ones?
I mean, one of them is like, you know, who today is asking for a reusable satellite? Um, and I would say there's like very few people that are, but they are asking for much lower lead times, much more reliable schedules, much lower costs, and much more robust infrastructure. So they're definitely banging down our door to answer those questions. The way that we deliver it is through reentry and reusability. There are other ways to do it that other companies have been trying to do, and it's working to various levels of success. But I think that's kind of the key, is that we are answering an existing pain point and problem with a novel solution, as opposed to kind of, on the government side, they write a requirement and they have the solution in mind, and they say, this is what we need and we want you to build it for us. That's a very defense prime kind of view of the world, versus we have a problem, we're not sure how to solve it, we think we do know how to solve it, and we go about proving that. So
And from these, you have the test coming up in February
yeah,
and several other tests, I'm assuming, as well
yeah.
in the later date. But when this is proved out and people can see, yeah, this works, what then becomes the big problem? How do you scale up from a dozen to 100 to 1,000?
Yeah. I mean, then, yeah, fundamentally, the scaling is the hard part. It starts off as hard to make one thing work once, and then it gets, much, much harder to do that many, many times in production. And that'll be a different scale of problem that we have to solve. It's a thing that we have our eyes on, but it's not something that we're solving today. Right? You make it work once, and then you figure out how to make it work well, and make it work at scale. And you have to have that in mind, but don't necessarily focus on solving that problem all in the beginning. And so, one of the things that we're going to learn from our first test flight and our first reuse is, what do we need to focus on and fix as we move from the technology demonstrator to the production vehicle, and the one that we'll build the fleet out of. And I, we don't we have ideas about what that'll be, but we don't necessarily know what technical challenges are going to be most important, or kind of what manufacturing challenges and refurbishment challenges are going to have the biggest impact. We definitely have a list of things that we are concerned about and that we have ideas on how we're going to fix. But to focus on those now without having the proof of a test flight and a test reflight would mean that we could very much be focusing all of our energy on the wrong problem instead of spreading that energy across a couple of small problems or a big problem in some other direction.
And I'm assuming as more and more units get produced and tested, it's a snowball effect of how
Yeah.
fast things are moving along. In your mind, at what point do you think this snowball is just unstoppable and you have it figured out enough to where, yeah, this is working and I can tell that this is already going to get copied by other bus providers before it's even in full scale?
Um, it's a good question. I don't know exactly when that will happen. We have there's like statistical significance on testing that goes from sometimes it's three based on the variance you're going to get, sometimes it's 10 of the number of samples, and it kind of depends on the physics that we're looking at, whether it's on the heat shield or whether it's metallic fatigue or composite fatigue, um, or thermal cycles of electronics and things like that. um, I think once we find the big problems, we will know how hard and how long it will be to solve those. But I would not say that we know exactly what the hardest problems are. We have really good ideas, um, and we have solved some of those with high cost solutions, and there are low cost solutions that we will employ kind of over time. But to say we know exactly when that'll happen, I'm not sure. I would say, once we get five reentries successful, we'll be in a pretty good spot. And then once we get, five reflights of the same vehicle, we'll also have a really good idea of that.
Yeah. And scaling so fast, you've done a terrific job with this. Tell us about how you've built this team. What was it like, the first month of this idea, and how have you grown up into the point today?
Yeah, totally. So, we now, I think we're at 17 or 18. We now have all the disciplines kind of filled out, all the expertise that we need to make this work. And we're kind of, adding folks to the bench on each discipline for execution. And what I told each of these people when I hired them is that I designed a vehicle. I got a lot of things wrong. I got a lot of input from the very early team and advisors and things like that. But I did a whole bunch of stuff wrong. Like your first job on day one is find out what I did wrong and fix it, based on your discipline of thermal analysis, aerothermal heating, structures, packaging and layout, like AIT operations and things like that. And so every single person I've hired, I've said, I did a bunch of things wrong, and the early team did a bunch of things wrong. You're smarter than us in this respect. Figure out what we did wrong in that discipline and fix it. And that really excites people a lot, is to kind of have a bit of a starting place, but really have that strong ownership that they get to go fix those things. The other thing is that we've set a requirement on the entire engineering team that they have hardware and space. So these are people that have gone through the full life cycle of build, test, launch, operate, and hopefully have gone through some kind of failure investigation. We feel that you learn way more on a failure investigation about the 16 things that almost caused the failure, in addition to hopefully finding out that one thing that did cause the failure. When something is successful, you say, great, it all worked, and you move on to the next one, but you don't know about those like 16 things that were so close to, causing a failure of the mission. So building a team of really seasoned engineers has really been one of our secret weapons. And the way we do that is asking people what hardware they have in space and what happened with it, what are the details, what do they know about it, and kind of going through that process as we interview folks.
And where you're at now, up into the flight you have in February, what's keeping the team busy?
Oh man, what's keeping the team busy? I mean,
I'm
we have
sure
a lot.
there's a lot.
We have a lot of stuff to kind of get ready for that first flight, right? We're moving very quickly towards our first reentry flight, and so it is kind of finalizing design. We've completed our critical design review for the entire vehicle and the mission, but then it's kind of finalizing all the things that need to happen to get towards vehicle build, testing, integration, and then flight, and then getting ready for those operations. So it's across the gambit from working with our customers on the interfaces and integration plan to um, uh, you know finalizing our processes. We're a brand new startup, so we don't have the infrastructure of a highly trusted ERP system and MES system and all the other acronyms that help us build satellites. We have to build all of those or work with our partners and vendors to stand that all up and then test it before we build a flight one. So yeah, you can probably see it behind me. There's a lot of activity that's kind of going on in our shop right now, both on the engineering side as well as the kind of execution and technician side. So they're staying busy.
I love it. Well, Brian, if there's anyone who is listening to this recording and you wanted them to have one big takeaway from our conversation, what would you want that to be?
Um, yeah, one thing that I learned at Starlink is the scale and the consequence that one engineer can have on the world, right? We brought connectivity to places that had never had connectivity, and that was a really big gift that I got from the Starlink program. Our goal is the same scope and magnitude and consequence of what we are trying to do that affects everybody on Earth via giving much more robust, high cadence, high trust space infrastructure. And so, to me, it's important that when I get up every morning, I'm doing something that I think is immensely important to the world. And so that's what, gets everybody on our team up and gets them very excited is the scale that we are trying to hit here. And so if that's really exciting to you, whether you're an earlier, like, intern level or earlier stage engineer, which we're hiring soon, but not quite yet, to senior seasoned engineers that have been through that process and want to do that again with a very novel problem that's very challenging. We'd love to talk to you.
I love it. Well, Brian, this has been a great conversation. I want to thank you
Yeah,
so much for taking the time to join us today.
absolutely. Thanks a lot for your time. It was great. Appreciate it.
Thank you so much. Take care.